Another voting method that was used is called Jeffersons method. Now Jefferson's method uses something a little bit different. Rather than trying to find extra seats and give it to the highest decimal, Jefferson's method is one that plays with the divisor. So you go through the same process and you start finding the standard divisor. Alright, so the standard divisor is going to equal, now in this case, the population is 5,800, total population, and you're going to divide by how many seats are available, and it's a little bit bigger now, it's 20 seats. Alright, so 5,800 divided by 20 seats is 290. Alright, so what's going to happen now is we're going to take each one of these numbers and divide it by 290. So if we take 900 and divide it by 290, we get 3.103. The next one divided by 290 would give you 4.138. The next one would be 2.414. Next one would be 5.517. And anytime you want to pause the video and try the calculation yourself to make sure you're coming up with the same answer, pause away. And the next one is 4.828. Now if we round these, we're going to get 3, 4, and they round down, 2, 5, and 4. If we add these up, let's see, that's 7, that's 9, 14, that's 18. We're too shy. Now unlike Hamilton's before, where you just kind of gave the 2 to the largest decimal values, this one, oops, I forgot to put my standard divisor here. This one requires what's called a modified divisor. So what you're going to do is change your divisor to change your answer. So it ends up with being 20 after you round down. So the ones that are going to change more than likely, if you make the divisor smaller, are the largest decimal ones. So what I would do is concentrate on one of these two, pick a number that's smaller than 290 so that the answer you get down here is going to get larger. So pick smaller to make larger. And if we had to go the other direction, then you would pick a larger divisor to make this thing smaller. So sometimes what would happen, spreadsheets are beautiful for this. You can pick numbers and see where it goes from larger to smaller and then just pick a number in between. But because you're going to be doing this mostly on a calculator, the best thing to do is to pick one of these numbers, which is, I would pick the 4828, and see what divisor under 1400, close to 290, but we're going to make it a little bit, in this case, smaller, so we can make our answer 2 larger. Alright, and once we can change this number, we're going to see what will change the 1600. So I'm going to eventually go through and erase some of this, but let me do some calculations. Let's say we make the divisor 270. So if I take 1400 divided by 270, we end up with 5.18. So that would change this 4 into a 5. Hopefully it doesn't change any of the others, but this is a guess. Now if I do 1600 divided by the same thing, divided by 270, I end up with 5.9. That doesn't exactly push this one over. So that one changes up 1, but this one doesn't. And more than likely none of the others will that are smaller than 517 on the back end. So I'm going to try something else. How about 260? So I'm going to try 1600 divided by 260. That comes up to 6.15. That pushes it up. So what I'm going to try for my modified divisor, so what I want to try with this is a new divisor, and I think 260 is going to work because it changed the 2 largest decimals that I did have for 1600 and 1400. Alright, not just because they're the two largest numbers either. Their decimal values seem the closest to being rounded up. Alright, so let's go through and divide everybody by 600. So 260. Divided by 260, we get 3.462. 1200 divided by 260. And there's a lot of numbers that'll do this, so this is just, guesswork. You don't have to divide by 260. On my spreadsheet, 250 worked perfectly fine too. 615. And then 700 divided by 260. 2.692. 1600 divided by 260 is 6.154. And 1400 divided by 260 is 5.38. 5. So then you go through and you round them again. So the rounded values would be 3, 4, 2, 6, and 5. And add them up, and let's see, that is 7, 9, 15, and that gives us our 20. So our apportionment for this one is going to be 3 for the first district, 4 for the next one, 2, 6, and 5. And this would be the split, or the representation for each region of our town for 20 seats. So where the Hamiltons, we just worked with the standard divisor. These newer methods always use a modified divisor. There's errors that could be made here. I played around with some of them where I couldn't find a modified divisor. So it would jump between like 21 and 19 and never land on 20. So there are some errors with this method also.